this is the continuation of the chapter 5. So we will continue with the assembly language. Okay, so our agenda for today is that I will introduce you about assembly language, and then the MIPS assembly language. What are the types of MIPS instruction? Okay, means that I will introduce you a simple MIPS instruction lah in the assembly language. Okay, and then we will extend to memory. Okay, memory, and then data transfer, and also decision instruction. So in this case, you will come across, okay, with not only assembly language, but also we will try to translate from C++ language, okay, C language to MIPS assembly language. Okay, so do remember from chapter 1, okay, I do touch about the assembly language ni. Actually, okay, from your C++ language, okay, they will translate into assembly language. It's just that you only see the compiler. Okay, you did not see the assembler. Okay, so this time around, okay, we will try to see what are inside the assembler. Okay, the assembler. So this is a simulator for assembly language. Okay, a simulator. It will try to simulate the assembly language and into a machine, and then they will try to execute to the processor. So this is the simulator that I would like you to download. Nama dia Qt Spin. Okay, so it can be in any versions lah. If you are using a Windows operating system like my PC here, so try to download the latest one. So it's working. Okay, so I'm using it right now in my Windows 10. Okay. If you are using a MacBook, so there's also an installer for the Qt Spin juga. So you can try it. Okay. Okay, let me start now. So I hope you can see the slides here. Okay. So what is assembly language? It's a basic job of a CPU, which means that the basic function of a CPU is to execute lots of instructions. Okay, execute lots of instructions. So every time you load your programs, okay, every time you load your programs, it contains lots of instructions. Okay, it contains lots of instruction. So one line of instruction can be one or more instructions. Okay, so the instructions are the primitive operations that the CPU may execute. So different CPU will implement different sets of instructions. Okay, so we call the set of instruction a particular CPU implementation, which is an instruction set architecture. So in a short form, I will call it ISA. Okay, so we have a lot of example of ISA or assembly language. Okay, for example, we have Intel 8086, which is used in a Pentium. Okay, Intel Pentium, at the latest Pentium 4 lah. And then IBM Motorola PowerPC, which is the old Macintosh. And then we have a MIPS, like what we will learn after this. And then we have Intel Instruction Architecture or IA64 for 64 bits. Okay, so most basically for the current version of the Intel punya architecture. Okay, so in the early trend of the ISA, they try to add more and more instructions to the new CPU to do elaborate operations. For example, VEX architecture had an instruction to multiply more polynomials. Okay, so in this case, they for and increase or complicated functions, so they try to add, instructions for this type of operation. So at 1980s, so the scientist named Peterson, Hennessy, Koch, Koch from IBM, try to introduce the reduced instruction set computing. So using the concept of reduced instruction set computing, they keep the instruction. So the ISA keep the instruction set small and simple. So the ISA in this RISC concept have a small and simple, so which makes it easier to build the fast hardware. So rather than using a complicated function macam polynomial ke, power of ke, semua tu. So what they did is that they just use a small and simple instruction. So small and simple makes it easier to implement and faster to execute. So what about the complicated operation? So they just let the software to do the complicated operation by composing simpler one. So that's why kalau kita tengok dekat dalam programming yang high level language, if I say high level language, high level language, let me use a pen. High, oh my god. So high level language, we call it as a high level language for the one that you become the programmer. So contohnya macam high level language ni macam C++, Java, HTML. Those are the programs that can be understood by the human. Pada human, so that's why we call it as high level language. So this type of coding or language, can build complicated operation. They can build complicated operation such as a software, browser, mobile apps, and everything else, right? So so to do the complicated operation is by composing the simpler one, such as a small library. They build up a small library to, for example, write file. To write files and everything else, and then other operations. So that is how the RISC concept come out lah. So what is RISC? What is MIPS? MIPS architecture is introduced by a semiconductor company that built one of the first commercial RISC architectures. So we will study the MIPS architecture in some details in this class. So why MIPS instead of Intel 86? Previously, your senior, they study about, they use 8086 assembly language. They use Intel 8086 programming language or assembly language. But it's not like their performance is not good. It's only the format. The format is quite complicated. They're quite complicated. Because of this, they have a lot of instruction. They have a lot of instruction. So rather than that, MIPS ni is simple and elegant. So they don't want to get bogged down in gritty details because of we don't want a lot of different type of instruction to do the operation. So MIPS is widely used in embedded apps. If I say embedded apps tu maksudnya macam ni, yang tengok dekat dalam gambar ni. If you look at the picture here, So most HP LaserJet workgroup printers are driven by MIPS-based 64 bits processors. So that's what we call embedded lah. Embedded computer, contohnya macam printer ataupun ni PS4. So if you have a PS4 ataupun mobile games yang joystick tu semua tu, most of them are using a MIPS. MIPS language sebenarnya. Okay. So why is that? It's very simple and fast. Okay. Very fast to execute in the machine language. Okay. And then, okay.